Okay, so this section is going to be on two more transformations of sine and cosine graphs. So far we've talked about what A and B do to the graphs of sine and cosine. So A, remember, is our amplitude. So that is the height of the graph from the midline to a high point or the midline to a low point. So if this is our midline, this is our amplitude, that height of the graph. Okay, and then for, cosine, it's like this. So here's our midline, midline to a high point, midline to a low point. That is our amplitude. B helps us determine the period. B itself is not the period, but B helps us determine the period. So remember, 2 pi over B gives us 1 full period of sine and cosine. All right, and today we're going to introduce 2 more translations. So C is going to be a horizontal shift. It's sometimes called a phase shift when we're talking trig, but it just moves the graph horizontally, just like we've seen whenever we have some value in with the x inside the parentheses, that horizontally shifts the graph left or right. So C is going to be called a phase shift or a horizontal shift. And it will also be where we start our graph. So for trig graphs, we always have our 5 critical points, and we've always been starting at 0, right, for our 5 critical points so far. But now this phase shift will change where we start the graph. So it's going to move it left or right. The thing we have to do too with the phase shift is if we have a coefficient of x, if we have a b value that is not 1, we must factor it out of both the terms inside the parentheses before we start identifying our phase shift and starting our graph. So we'll talk about that a little bit more later. The last thing we're going to identify is a d value, which is outside of the parentheses, and we'll talk about a vertical shift here. D will move the midline of the graph. So it's a vertical shift up or down, which we've seen before in other parent functions that get transformed. That value outside of the x, outside of that argument, when it's on the outside, shifts your graph up or down. And specifically for trig functions, it shifts the midline up or down. So we're still going to use A for amplitude and 2 pi over B for the period, which is going to be the end of our 5 critical points. And we'll go more specific on that in a second as well. Okay, for this one, we're going to identify these characteristics of the graph. The amplitude would be 1 because there's an imaginary 1 in front of our function. The period, our b value, our coefficient of x is 1, so the period is 2 pi over b. 2 pi over 1 is just 2 pi. Our phase shift, the key that we're seeing a phase shift is typically parentheses with the x. There is no phase shift here. And the midline then is going to be at 4 because this graph is going to shift up 4 units. Cosine of x plus pi, if we identify the amplitude, again, it is 1. The period, our b value is 1. So the period is again 2 pi over 1, or just 2 pi. Now we have a phase shift. So this graph has a phase shift. It's going to always move in the opposite direction as the sign in the parentheses, which we've seen again before with all kinds of parent function transformations. So the phase shift is going to be a negative pi. It's going to move to the left pi units. And the midline, there is no vertical shift on this, so the midline will be at 0 at the axis. Okay, f of x equals sine of x minus 2 pi minus 7. The amplitude, imaginary 1. The period, b equals 1 again, so our period is still 2 pi. Phase shift is going to be this value in here. It will be a positive 2 pi, so 2 pi to the right. And the midline, we have a shift down 7, so our midline will be at negative 7. This section, these 6 steps to graph 1 full period of sine and cosine are going to be super important, and you should use these to reference until you get the hang of it and can do it from memory. Step 1 is going to be to sketch the midline. So identify the midline, sketch the midline. Step 2 is going to be to sketch the amplitude boundaries, because the amplitude depends on the midline. Then, step 3 is going to be to find your C value. So find that phase shift. If you have to factor, because B isn't 1, you have to do that first before you find the C value. So find C, and that is going to be where you start the graph. So that's your first critical point. Number 4, you're going to find the period of the function. So 1 full rotation. And to find the period, we use 2 pi over b. You add 1 full period to the C value, which will give you your end point. So if we start at C, we add 1 full period, then that value will be the end point. So that will be our 5th critical point. So we have our C, which is our first, and then we have our ending point, which is our 5th. And then we will sketch in the midpoint, mark the 2 other critical points. So we always have our 5 hash marks, right, for those 5 critical points. Start, end, midpoint, and then the 2 that cut those in half. Finally, you are going to connect the points with curves, not with points, not with like arrows or mountains. Connect with curves and add arrows correctly. So showing where your function continues within those amplitude boundaries. We are not going to do all of the examples that are given here. I'm going to pull from ones that I feel like are helpful and important. So we're going to skip around in the notes a little bit. So we're going to do example 3 first. Sine of x minus pi plus 2. Step 1 in our graphing instructions are to identify the midline. So this plus 2 here tells us that our midline is going to be at 2. So there's our midline. Our amplitude is 1, meaning from that midpoint, we will graph the amplitude 1 above and 1 below the midline. Then we identify our phase shift, which is going to be plus pi, meaning our first point will be at pi. Then we identify the period. So our b value is 1. Our period will be 2 pi over b, which is 2 pi. We add 2 pi to the starting point to see where our ending point will be. Pi plus 2 pi is 3 pi, meaning the 5th point of our 5 critical points, or the ending of our rotation, will be at 3 pi. The midpoint, halfway between pi and 3 pi, is 2 pi. And then our other 2 little hashes will go halfway in between each of those. Then we just graph using the pattern of sine, which we know starts in the middle. So at our first critical point, we have a middle, then sine goes high, middle, low, middle. Then we just connect these with a nice curve. And there is our graph. And all of these must be done on your graph to get full credit. So I want to see all of it. Example 4, let's start with this. The amplitude is 2. The period, if we look at our x, or our coefficient of x, b is 1, so period equals 2 pi over 1, so period is 2 pi. Phase shift, it is going to be left 2 pi, so negative 2 pi. And our vertical shift will be down 1, meaning the midline is at negative 1. So then to graph this, step 1 is to sketch our midline at negative 1. Step 2 is to sketch the amplitude. So 2 up and 2 down from that midline. Shows us our boundaries up and down. Our phase shift is going to start left 2 pi, negative 2 pi. And the period is 2 pi. So to find our ending point, we take our starting point, add 1 full period, and we find that our end point will be at 0 at the origin. Our midpoint will be halfway between negative 2 pi and 0, which is at negative pi. And then our little hash marks in between to get our 5 critical points. This is positive sine, so it's going to follow the regular pattern. It will start at the midpoint. then go high, back to the midline, sorry, then low, and then back to the mid. And then we sketch our graph. Okay, I am going to skip this page because I think we get it by this point. Let's look at number 5 because something else happens on this one that we need to make sure we pay attention to, which is this negative sign. It's not going to affect anything until we get to the actual plotting of our points. So the amplitude is still 1 because it's always the absolute value of that A coefficient. The period, B is 1 again, so period is 2 pi over 1, which is 2 pi. There is no phase shift because there's no parentheses with the x, and then our vertical shift will be up 3, meaning our midline is at 3. So to graph this, we'll do our midline at 3, our amplitude 1 up and 1 down from 3. Phase shift is none, meaning we start at 0. Actually, I'm going to put this down on the axis. Start at 0. 1 full period is 2 pi, so we're going to end at 2 pi, sketch our midline, and then divide each of those halves in half. Okay, sine starts in the middle, but because this was negative sine, instead of going up first, it will go down first. Oops, not there. Up, middle, up, middle. So this is going to look something like, oh, that was not right. Hold on. This is coming from here, like that. Okay? All right, now let's look at these 2 examples. These are the toughest ones and the ones that you're going to want to make sure you pay attention to because we have this situation where our coefficient of x, our b value, is not 1. So we have to rewrite this in order to find the correct phase shift. So first, though, we can identify everything that we can see without doing that shift. Amplitude is 2, and there is no d value, which means there is no vertical shift, and the midline is at 0. The period, this is still our b, so we can find the period doing 2 pi over 1/2. Copy, dot, flop, period will be 4 pi. To find the phase shift, I'm going to rewrite this and factor out the 1/2 from every term inside the parentheses. So I'm going to make a bracket, and then I'm going to factor 1/2 out of both of these. When you factor out 1/2, what you are essentially doing is multiplying the second term by the reciprocal of 1/2. The reciprocal of 1/2 is 2. I'm going to multiply the second term by 2, which will give me 2 pi inside of that parentheses. Now I can correctly see my phase shift, which is going to be to the left, 2 pi. If you don't do that and you put the phase shift as negative pi, your graph will be incorrect. So just make sure that you are watching for that coefficient so that you can properly identify what you need to and graph correctly with your phase shift. So if we graph this on our own, start by identifying and labeling your y-axis. We can just go by ones here. And identify our midline, which is at the axis. So the midline is just going through here. Our amplitude is 2, so our boundaries will be up 2 and down 2 from the midline. Our phase shift is negative 2 pi. So if I go, let's call this negative pi and then negative 2 pi. So this would be my starting point here, negative 2 pi. If I add 1 full period, which is 4 pi, to my starting point, my ending point will be at positive 2 pi. So I can call this pi and this 2 pi. So this will be my ending point. Cut it in half at 0, and then identify my other 2 critical points so that I have a total of 5. This is sine. It's positive, so it's going to follow my regular sine pattern. Mid, high, mid, low, mid. And then graph. Arrows, done. All right, last one. Okay, lots of things to notice here. Negative sign with our amplitude, and we've got this fraction with our x, with our b, so we have to make sure that we factor that out. Let's just start with the things we can see. Amplitude is going to be 1. Midline and vertical shift will be up 2. So our midline will be at 2. Our period, we can use this for our b value, 2 pi, over 2/3, copy, dot, flip. So our period will be at 3 pi. Then, in order to correctly identify the phase shift, I'm going to pull out the 2/3 and factor it from both terms. So this becomes x. I'm going to take my pi over 6, and I'm going to multiply it by the reciprocal of 2/3, which is 3 over 2. Then I can cross simplify, and pi over 4. Now I can see my phase shift. My phase shift is going to go right, pi over 4. Now I've got everything I need. I can start sketching my graph. So here we've got our y, our x, 1, 2, 3, 4. We'll go just by ones. So always label your y-axis indicating what units you're going by. And then let's start graphing our other pieces. So let's call this pi over 4. We can mark 1, 2, 3, 4, 5 critical points, but we need to graph and label the end point and the midpoint as well as the starting point. So to find the end point, take our phase shift, starting at pi over 4, add 1 full period. In order to add these, we have to get a common denominator. So we're going to multiply top and bottom by 4. So this gives us 13 pi over 4. Okay, and then to find the midpoint, we're going to average the two of these to find their halfway point. So pi over 4 plus 13 pi over 4 is 14 pi over 4 divided by 2, copy dot flop, gives us 7 pi over 4. That's our 7 pi over 4. Okay, let's get drawing. Midline is at 2. Amplitude is 1, so we'll go 1 up and 1 down from 2. And then we can graph our 5 critical points. This is negative cosine. So typically cosine starts high, but because it's negative, it's going to start low on our first critical point. Low, mid, high, mid, low, and continuing on both sides. So there is our graph of that. So marking all these pieces on your graph and making sure it's super neat is what I'm going to be looking for.